Set up the initial Simplex Tableau for the following problem. Okay, farmer has 100 acres of available land on which he wishes to plant potatoes, corn, and cabbage. Cost $300 to produce potatoes, $60 for an acre of corn, $180 for an acre of cabbage. Maximum of $20,000 to spend. Tax of $5, $10, and $15 for potatoes, corn, and cabbage. And the farmer does not want to pay more than $900 in taxes. He makes a profit of $120 per acre of potatoes, $40 for corn, $60 for cabbage. Okay, there's a lot going on there. All right. First thing I see, though, or first thing that jumps out at me is that he's talking about profit. So I know this is a maximize problem. Just like in the last chapter, when we maximized problems, maximized profit, we're doing the same exact thing. So you ought to be able to set this up because you did the last section, okay? We're talking about 120 for potatoes. Let's call potatoes X and corn Y and cabbage Z. We can use X, Y, and Z. We don't have to use X1, X2, X3. You can if you want. It doesn't really matter, though. So let's say 120X plus 40Y plus 60Z. Okay, that's my objective function. Now, go back through and let's try to get the constraints. Subject to, get the constraints. Now, this one's tricky because it doesn't just come out and tell you what to do. But when the farmer has 100 acres of available land on which he wishes to plant a mixture of potatoes, corn, and cabbage, that's a very common inequality symbol for a lot of problems. It's a total. There's a total of 100, and he's going to have some kind of mixture. So he might do like 33 acres of this and 33 acres of this and 33 acres of this. Okay? But if you really think about the numbers, that's a constraint. Whatever these three things add up to has to be less than or equal 100 acres. As you keep going, it talks about cost for potatoes and for corn and for cabbage. And it says he has a max $20,000 to spend. So you can put those three things into one inequality. 300x plus 60y plus 180z is less than or equal to 20,000. And then the last one, they talk about taxes, 5, 10, and 15 for potatoes, corn, and cabbage. And he does not want to pay more than 900. So you're looking for limitations. That's a limitation. He can spend less than or equal 900. So it was 5, 10, and 15. So 5x plus 10y plus 15z. Okay. Now, to set up the problem, we also would have, the acres have to be non-zero. And we would also have, I'm not there yet, I guess, for slack variables, but that would be your setup. If we were doing this problem last chapter, that would be the setup, and we'd graph it. But the problem with graphing is this would be a three-dimensional graph, and that's going to be pretty hard. So we're going to have to use the Simplex. For Simplex to work, we're going to set up the initial Simplex Tableau. That means I need slack variables. For each of these inequalities, I'm going to install a slack variable, S1, S2, S3. And so, those things would have to be non-negative. But that's not super important for what we're trying to do here, which is make that initial Simplex Tableau. So look at your variables. You should see 7 of them. Let's list them out. You've got X and Y and Z and S1, S2, S3, and Z. Or actually, we didn't call it Z, did we? We called it P. So let's call it P. Fine. P for profit. Look at your first inequality. I'm going to skip a step here. Earlier, we did a problem where we went from the problem over here with the slack, add the slack variables to change them into equations and then we took those equations and we made into the table. I'm just going to completely skip this because I can see this from here. You're going to have that S1 and it's going to be right there. Okay. I think we should be able to skip a step and go straight to the table. Okay. So we look at that, well, it's an inequality now, but it's going to be an equation as soon as I add the slack variable. You would see x plus y plus z, and then we install an S1 slack variable. We do not have S2 or S3 or P in that equation now, and it equals vertical bar 100. Look at the next line. Okay. The next line, you've got 300x, 60y, 180z. We don't have an S1, but we're adding an S2 that time. No S3s, no P's, and it equals 20,000. And then we go to the third one. We've got 5x, 10y, 15z, 0s1, 0s2, 1s3, 0p, and it equals 900. Underline. Make that cross between the vertical line, which represents the equal sign, and then the horizontal line is going to separate my constraints from my objective function. My objective function is this thing, but keep in mind, you have to subtract this 120 over to put it in standard form. Okay, so if I subtract that over, that's going to make negative 120x. And I'll have to subtract this over, and that'll make negative 40y. And I subtract this one over, and that's going to make negative 60z. I didn't need any slack variables because it was already an equation. And don't forget that there was a p in there. A lot of times students will forget about that p, but there's a p. And also, if you've subtracted everything out of there to clear it out, you've cleared everything out, it's going to equal 0. Bless you. So there is your initial Simplex Tableau. Okay, we good? Basic variables are the variables we can actually solve for. Okay. And I know that's hard to understand, okay? But look at S1, okay? S1 is a basic variable. Basically, if you think about your Gauss-Jordan process, you look at this number right here and this number right here. And just think about how we did Gauss-Jordan. We could say that S1 is equal to 100. S1 is equal to 100. And if we did S2, okay, S2, we would be looking at this number right here, which would force me to look at this number right here, and we would say S2 is equal to 20,000. And if we did S3, we'd be looking at this number, and we'd say S3 is equal to 900. And if we did P would force me to look at this number 1, and I'd look at this number 0, and I could see that P equals 0. The basic variables are the ones that we can actually solve for. But if you look at X, the problem is you don't know what to look at, okay? Do I look at this number or this number or this number or this number? And if I don't know which one of those numbers to look at, I don't know which one of the numbers on the right to look at, I wouldn't know how to solve for those variables. So in this problem, the ones I've marked in yellow are the basic variables, and these ones I'm marking in orange are the non-basic variables, okay? And what's going to happen is non-basic variables equal 0. Okay, every time you come to that, non-basic variables equal 0. And so if I had to come up with a solution, okay, a solution, basic feasible solution is just basically the solution, or a solution, I guess, not necessarily the optimum solution. But for this one, x equals 0, y equals 0, z equals 0, S1 equals 100, S2 equals 20,000, S3 equals 900, and P equals 0. Okay, that would be one of the solutions. If you're thinking about the picture, okay, if we could graph this thing in 3 dimensions, we just found one of the corners. That profit's not the maximum profit, though, so we would have to look at one of the other corners. Okay, that's probably the hard part about today. Let's look at number 3. Read a solution from the following simplex tableau. Well, let me identify the basic variables first, okay? Basic variables like this one, and this one, and this one. These are the ones that are easy to find, okay? We do it just like we did when we solved Gauss-Jordan, okay? If you look at x2, your eye must be drawn to the 5. And that 5 draws your eye to the 45, okay? And so x2 has a value. There's x1, x2, x3. x2 has a value of 45 divided by 5, which is 9. Okay? S1, S2, S3. If you look at S2, your eye should be drawn to this 2, which should draw your eye to this 17. Okay? Think about the Gauss-Jordan process. You can ignore a lot of the other numbers and just look at the 2 and the 17, and your S2 value is 17 halves. Likewise, your other basic variable is Z, and your eye should be drawn to this 3, which also draws your eye to this 90. Can anybody tell me what Z would equal? Z is going to equal 30. 90 divided by 3 is 30, okay? Those are your basic variables, the ones we can actually solve for. The others, I wouldn't know which of those numbers to look at. I wouldn't know which numbers to look at. I wouldn't know which numbers to look at. Those are your non-basic variables, and non-basic variables are always going to equal what? 0. So it says read a solution from the Tableau. Okay, that is a solution. It's not necessarily the optimal solution. Okay, it's one of the corners. If you drew a three-dimensional figure here, you've got one of the corners, but it's not the optimal. And how you're going to recognize it is when you see negative numbers on the bottom row. Okay, so earlier I said negative numbers are going to be important. When we see negative numbers on the bottom, we know we're not at the best solution. As soon as all those negatives disappear, boom, that's the best one. That's what we will want. Okay?